higher order function called fold. And fold is a function that takes in a list of elements and returns a single element. So it folds all the elements into one value. So fold is a higher order function because of one thing. So usually when we have a function, the function only takes in ints, strings, int lists, like other data types that we normally see. But fold is a higher order function because one of the values that it takes in is another function itself. So we have a function taking in a function. All right, so when we're going through the fold method, you have to keep track of three things at all times. One is x, and x is the element that we are currently looking at in the list. Two is acc. Acc is a keyword that stands for accumulation, and acc is the result of calling fold on the rest of the elements in the list, and I'll explain that in a minute. Three is our result value, so what the whole call to fold will result in, because we know that every function results in a value in OCaml. So let's consider an example with this list. So we have 12, 5, 2, and 28. And we want to use this function. We want to put this list into this function. And this function is called greater than. And greater than will return the number of elements in the list that are greater than 10. So we're going to go through, and we see the greater than, the function greater than is just a call to fold. And we have fold, we have our three arguments. We have our function, the function we're taking in, the base case, 0, and the list that we're taking in. And we're going to pretend that L is this list, okay? So let's start off going through fold. Number 1, what is the element we're currently looking at? That's x, okay? 2, what is the acc value? So acc is calling fold on the rest of the elements in the list, right? So initially we're calling fold on this entire list, but our first acc value is calling fold on these elements in the list. Okay, 3, what's our return result value? Okay, so x, is x greater than 10? Yes, so we're going to return 1 plus acc. So right now our return value is 1 plus acc. Okay, that's great. I have no idea what acc is. Let's figure out what acc is. Okay, so now we're looking at this part of the list. Forget that this first element is here. Number 1, what is the element we're looking at? What is x? X is 5. Number 2, what is acc? Our new acc, let's call it acc prime, is calling fold on the rest of these elements. Number 3, what's our value? Okay, is x greater than 10? No, so we're going to return 0 plus acc. So this whole big acc is replaced by 0 plus acc prime. Okay? So our big acc is replaced by 0 plus acc prime. All right, now let's figure out what acc prime is. So we're just looking at these two elements in the list, 2 and 28. Okay, what's our x value? Our x value is the first element in the list. 2, what's our acc value? That's calling fold on the rest of the elements in the list, so just 28. So let's call this acc double prime. Okay, so what's 3? What is our result value? So is 2 greater than 10? No. So we're going to return 0 plus acc, acc double prime, right? 0 plus acc double prime. All right, that's great. Now let's figure out what acc double prime is. Okay, acc double prime is just this 28. So what's the first element in our list? That's x. And then what is our new acc value? Acc is calling fold on the rest of the list. But you say there's nothing else in the list. Well, remember that at the end of any list, there's always an invisible empty list. So this is our new x value, but the empty list is our new acc triple prime, okay? So number 3, what's our result value? So 28, is 28 greater than 10? Yes, so we're going to return 1 plus acc triple prime. Okay, finally, let's figure out what acc triple prime is. Okay, so remember in the definition of fold, there's 2 cases in pattern matching. It's either when the list is empty or if there's an element, at least one element in the list. So we're calling fold on an empty list. And we know from the definition that that results in the base. So what is our base in this example? Well, fold, we have our function, our base, and our list. So our base is 0. So we're going to return our base. So we have an empty list, and we're going to return our base, and our base is 0. So at triple prime is just 0. So this results in 2, and that's correct because there are exactly 2 elements in our list that are greater than 10.